Unit 10, Lesson 2, I can calculate the measure of angles formed by intersecting chords. So these are chords, endpoints on the circle. And what we want to talk about today is the measure of angles, and we don't have a central angle. A central angle, its vertex would be here. So maybe it's something like this. We know that angle would be the same as just the arc it intercepts. So we used to be dealing with that, and these are the same for a central angle. Then the day before, lesson before, we talked about the inscribed angle. Notice its vertex isn't at the center, but it's on the circle. And this one was equal to half of whatever this is. Half of whatever this is. So again, if this is 100 degrees, then this is 100 degrees. But if this is 100 degrees, then this is 50 degrees. So that's half. But the question is, what happens if the vertex is not at the center and it's not on the circle? What happens if it's floating in the middle? So look at this angle right here, for example. And these are the same because they're vertical, right? Look at these angles. What's the measure of this angle 3 right here? I mean, its vertex is not here at the center, and it's not on the circle. So what's its relationship? That's what we want to figure out today. And like before, we're going to use prior knowledge and relationships to figure out this new relationship. So here I go. I'm going to start with a kind of an informal proof here. I'm going to work off the right side with the geometric notation. So I'm going to start with angle 1, and then I'm going to go to angle 2. And if you look at angle 1, and I turn the light on inside angle 1, notice it intercepts this arc here. So again, angle 1 would intercept this arc. Just walk down each arm, so from N to R. That's the intercepted arc. What kind of an angle? Well, notice the vertex is on the circle. So that's an inscribed angle. So its measure is equal to half of this arc. So I'm just going to write that relationship down. The measure of angle 1 is equal to this arc, NR. Except I'm going to take half of it. Another way to write it would be arc NR over 2. Either way is fine. These are the same thing. What would be my reason why? Why would that be okay? Well, that's just the definition of an inscribed angle. Angle is equal to half of its arc. So what about angle 2? Well, if you turn its light on, we're looking at the same situation. It's an inscribed angle as well, because the vertex is on the circle. So angle 2 is equal to half of minor arc KB. So I can come down here and do the exact same thing. Measure of angle 2 is equal to half, but this time of arc KB. Okay, great. So I figured out this relationship. This angle is half of this. This angle is half of that. I know that. They're inscribed angles. Previous lesson. Inscribed angles. Okay. So what's next? How does that get me to figure out how angle 3 relates to everything? And it turns out that there's a key relationship. And I'm going to redraw some of this over here for just a moment. I'm going to take this triangle here that angle 1 and 2 are in. Here's angle 1, here's angle 2. And look how I'm going to extend this way. So you can see this piece I'm taking right there. And here's angle 3. And we remember from prior units that angle 1 plus angle 2 actually equal angle 3. And that's called the exterior angle theorem. So the measure of angle 1 plus the measure of angle 2 actually equals the measure of angle 3. And that's the exterior angle theorem. So we're going to use that relationship. And then the nice part is I can take each of these first two relationships, that this angle is half of this and this angle is half of that, and I can substitute them in. I mean, look, the measure of angle 1 is right here as well. So where I see this, the measure of angle 1, I can substitute this expression. That is really half of its arc. This is half of that. So I'm going to put half of NR right in here. So 1/2 of arc NR. I'm going to do the same thing, and I'm going to substitute in here as well. And so I'm going to take half of arc KB and substitute that in there too. So again, where I saw arc 1, I put this. Where I saw angle 1, I put that. And the measure of angle 2, I put this. Here and here. There I go. This is just substitution as my reason why. And as I zoom in a little bit closer, what does that allow me to do? Well, you see there's a 1/2 here and a 1/2 here. I can factor those out and just put the 1/2 out in front. And that's really the distributive property. It's just the reverse, isn't it? I mean, if you multiply the 1/2 in with distribution, you get this. Now, I could rewrite this whole thing without the 1/2 in front. Instead, just a big long fraction bar over 2. It's the exact same thing, like I did up here. 1/2 out in front is the same thing as the expression over 2. So what's the point of doing this? Well, now I'm actually going to flip things around. I'm going to put the measure of angle 3 over here and this expression over here on the right, mainly because it looks cleaner that way. And I am going to do what I said. I'm going to rewrite this, the measure of arc NR plus the measure of arc KB all over 2. And when you switch sides like that, that's just called the symmetric property. And why did I do that? Because look what we actually came up with. The measure of angle 3, which is right here, relates to this arc and this arc. So measure of angle 3 relates to this arc and this arc. How specifically? This angle here is equal to this arc plus this arc, and then divided by 2. That's kind of a cool relationship. So when the vertex is just floating out here in the middle, and it was created by 2 chords, this angle here is equal to the sum of these 2 arcs, and then divided by 2. That's also known as the mean. It's also known as the mean. So this plus this divided by 2. So my overarching relationship here is that the measure of my angle is equal to pretty much arc 1 plus arc 2 divided by 2. This is the most important relationship summary here. Measure of the angle is equal to arc 1 plus arc 2 divided by 2. This is kind of like the mean. It's not kind of like, it is. Let's go and see if we can apply that. So look here in the guided practice. My find in this case is solving for x, okay? But this is the most important part. Is that the center of the circle? And I don't know. I can't assume it is. It didn't tell me that it is. So I can't assume that that's the center of the circle. Open this up for a moment. So it's not going to just be 105 degrees. Instead, I realize these are the same by vertical angles. Okay, these are the same. And the relationship is if you turn the light on right here in this angle, and you know it's the same as this one because they're vertical angles, now go find the arcs that they intercept. The light would intercept this one and this one. Notice how the angle I'm looking for matches the 2 angles I have, the arcs I have. And then I'm going to go ahead and write my relationship, probably 100 times. The measure of the angle is equal to arc 1 plus arc 2 over 2. X is the angle, 105 and 30 are the arcs, Go ahead and reduce, or rather simplify. You get 135 over 2. You can leave it that way. I'm totally fine with that. Or go do the long division, and you get 67 and 5/10 degrees. No problem. That's the relationship. Now watch how I'm going to try and trick you. I'm going to come over here. You can hit pause and try this one on your own if you'd like. The first thing I'm going to realize is that the vertex isn't on the circle. It's not inscribed. It's not at the center of the circle. It's not central. Instead, these angles here, when I turn their lights on, intercept this arc here and this arc here. And the relationship when this happens, when these two chords make this, is that this angle is equal to the mean of these two. So I'm going to write down the equation yet again. The measure of the angle is equal to the sum of arc 1 and 2 over 2. Why am I writing this formula every time? 1, it helps me memorize it. 2, it's going to be crucial because take a look, don't get tricked. Where does the 95 go? Do I put the 95 and the 30 just here and here? No. 95 is what? The angle. So 95 goes over here. What are my arcs? Y and 30. Look how easy it would have been to put 90 and 30, 95 and 30, just in for these two. Very easy. Absolutely the most common mistake, so please watch out. Here's another most common mistake. People are like, ooh, 30 and 2, let me reduce. Absolutely not. This y is also over 2. So what we can do is multiply both sides by 2 and get 190 degrees. This is y plus 30, so we just undid the division by 2. And then I can subtract 30 from both sides and get y is 160 degrees. Very easy to mess up in multiple locations there. Be careful. Finally, last one, we're solving for z. That's my find. Let's write out the relationship. The measure of the angle is arc 1 plus arc 2 over 2. And here's something that's even trickier. If you go and you turn on your lights, notice for this arc here and this arc here, which angles would I have to turn the lights on for? This angle, I'd have to turn its light on to intercept this arc, and I'd have to turn this light on to intercept this arc. Well, wait a minute, I don't have an angle measure there. I don't know what this is. I know that's 75. How could I find that? And you already know that this is a linear pair. So 75 plus this is 180. And so if you go and figure out what that is, it turns out 180 minus the 75 is equal to 105. So this angle here, and of course this one, because they're vertical angles, are both 105. But it's very easy to mess up and use 75 here for the angle, when that's not true. So I'm going to put 105 here, because of a linear pair, and then I can put 120 and z in the other spots. I can then multiply both sides by 2, as we did before, get 210. Then I can subtract 120 from both sides. And this becomes 90 degrees for z. So again, I suggest writing the formula out each time, making sure to annotate on your diagram so you find the correct angle, goes in the right spot, and intercepted arcs. Good luck.